with roughly 10 to 15 meters of pure fresh water sitting on top of the Arctic Ocean that could be exported and could work on the North Atlantic. Now, what are we actually seeing in terms of transitioning fresh water from the Arctic into the North Atlantic along these blue paths here? That is the freshwater exit route in the East Greenland Current. If we are looking at the Norwegian Sea here is depth, here is time, we see that since about 2 to 3 decades, the upper layer of the Norwegian Sea is freshening, so there is an increased freshwater export. We do see the same for the Greenland Sea, which is located here. And if we are adding all that water up, we have about an increase of 2,500 cubic kilometers of fresh water sitting over that region that has been accumulated. We are going further down to the Labrador Sea. Here is again a time series, 1960 to 2005. 3,600 meters. The red colors are high salinity, the blue colors low salinity. You see that the entire water column is actually freshening. So we are exporting fresh water into the North Atlantic. You don't have to look at any detail of these curves. What I want to point out here is in a publication that Dixon and others produced in 2002, at any of these locations here, and there are about 10 of them, they see freshening over the past 4 decades. So the entire area here in the North Atlantic is actually freshening. There is fresh water added, and the fresh water is coming from the high north. So we summarize that then. What we see is we have melting sea ice, so there's fresh water coming from removing sea ice. We have higher river runoff, which adds to the freshwater export. We have an increase in precipitation over evaporation. That adds to the export. And we have Greenland melting, which adds to the freshwater export. And what it leads to is a freshening of this entire area here that is at the headwaters of the conveyor belt. How much does that really do if we try to quantify that? If we look at what we would call a steady state or natural state, we have freshwater export through Davis Strait of about 100 millisquare which is about a tenth of the total river runoff on the globe. Through the Iceland Scotland overflows, we have about 130 millisquare. Hudson Strait 35. Greenland at this point very small contribution. The total freshwater that the global ocean circulation digests basically and deals with is about 250 to 300 millisquare. Now, what can we expect in terms of additional freshwater that would really change the way this circulation down here works? So the best estimates I could come up with and could find in the literature is that we will have an additional 15 millisquare through warming and precipitation over evaporation increase, an additional river runoff for a 3 degrees Celsius warming of about 20 millisquare. If we remove over 50 years about half of the sea ice, which has been sustained 15 millisquare. Not big, these numbers, compared to the 250 that are there in the natural state. But then if we look at Greenland, and if we say we take the volume of the ice that is there, and we melt it over 500 years, which is a fairly long period of time, we would get a sustained additional freshwater flux of 90 millisquare 180 millisquare foot. If we do it over 1,000 years, which is at the upper limit of what most of the models say, we would have about 90 millisquare foot. If we add these up, we will get an additional freshwater flux of about 150, 250 millisquare foot, roughly in the same range as what nature does by itself. Now, how would that play out in public models? If we are not looking, if we are not adding the effect of global warming, and we are adding roughly 0.1 square foot or 100 millisquare foot, that means about a little bit less than one half of what we can expect as additional export. model simulations are shutting down the conveyor belt with atmospheric cooling over the northern hemisphere of, let's say, 4, maybe up to 6 degrees localized here over the North Atlantic. Now, what would happen if we are running the same scenario with increased CO2 and the associated warming? Now we get that picture. So instead of a cooling, we are just getting an offset of the warming mainly located over the North Atlantic. And this is run for different scenarios of the IPCC emissions. So even if in a warm world, by melting quite a bit of ice in the north and thereby shutting down the conveyor belt, if we're able to do that, we will not fall back into an ice age or into a significant cooling, but we are simply offsetting part of the warming that we are expecting from the runs of coupled models in the greenhouse world. I will skip over these pictures. They are basically showing what is being done to measure that effect. And just to finish off my talk, just show you a few of the impacts that have been outlined in a report by the Arctic Climate Impact Assessment that was released 2 years ago. And if you are just looking at sea level rise as it is projected by these models, and note that all of these models, no matter what their amplitude is, they are all smooth. What we have seen in all the records I have shown is that there is quite a bit of variability that nature imposes. So we cannot necessarily, even if these amplitudes are right, we in all likelihood we won't get these smooth curves. There will be most likely more rapid and more slow phases of these effects. So if we believe these projections, and we say by about 2100 we have roughly 1 meter of sea level, or 3 feet of sea level increase, then this would be the portion of Florida that would be submerged. And as Wally pointed out, there are quite a few low-lying countries in Asia that would be affected severely by that. We are looking at shipping routes. If the sea ice is melting back, then all of a sudden the Arctic will experience much more shipping, and that will have socio-economic effects on the coastline, specifically along Siberia, where the Russians are already modifying their harbor infrastructure to accommodate more shipping. In terms of travel over the Arctic, the tundra travel times are getting much shorter. There was an interesting article in the New York Times a few years ago that sort of shows this shortening of the travel time, and that was, of course, related to an economic issue because it would complicate the exploration of oil. Entire communities are being moved right now away from the coast because the thawing of the permafrost along the coast and the rising sea level are eroding the coast, and thereby moving the structures that are built there close to the ocean, and they eventually would basically be submerged. So I want to sum up and basically conclude that if we are looking at present observations and put them into the context of past records and extrapolation in the future, we have to conclude that Arctic change is real and that it is in large part driven by anthropogenic change. And in fact, there are no good reasons not to expect a secular Arctic change with all the increase in greenhouse gases. The Arctic shows the strongest system-scale environmental change signals right now. We believe that there is an amplified global change signal. We have to look at the Arctic in the context of studying global change. And in order to settle all the questions that are raised by these observations and by their interpretation, we really have to sort of come to integrated studies where we combine observations, modeling, and process studies to sort of pin down the projected trajectory of the Arctic system with narrow error bounds. So what I would suggest to do is now move directly to Richard's talk, which will deal with clouds in the southwest, and then we will take questions at the end of